4.1, that is somehow near the end. I want to compute what is the value of y. Or when x is equal to 2.5, so somewhere at the center, I want to compute what will be the value of y, etc. Okay. So for that, I split the topic into two cases. One is the interval is at equal intervals. For example, either 1, 2, 3, 4, etc. or 2, 4, 6, etc. That is, it is equally spaced interval. And then in general, it is x0 and then x0 plus h, x0 plus 2h, etc. x0 plus 2h, x0 plus 3h, etc. That is, we consider that it is equally spaced, x1, x2, etc. The corresponding y is given, that I denote it as y1, y2, etc. Okay. So first we will assume that it is equally spaced interval. We will, in equally spaced interval, there are three formulas are there. The first formula is Newton forward interpolation formula, and the second formula is Newton's backward interpolation formula, and the third formula is Stirling's central difference formula. Okay, so we will learn one by one. So first let us see what is meant by Newton forward interpolation formula. You assume that y equal to f of x is a function, but we don't know the function. We know only the values. The values of the function at x0, x0 plus h, that is x1, x0 plus 2h, that is x2, etc. The corresponding value is y0, y1, y2, etc. Suppose it is required to evaluate the value of f of x for x equal to x0 plus ph, where p is any real number. Okay. So as I told you earlier, I want to evaluate the value of the value of y at x equal to 1.2. Okay. So in that case, what we do is, we already know that yp, okay, yp is nothing but the value of f at xp, and xp is nothing but x0 plus ph, and x0 plus ph we can write it as e power p of f of x0. And we know the relationship between E and delta. We know that E equal to 1 plus delta. Therefore, in place of E, we can substitute 1 plus delta. Therefore, you will get 1 plus delta power. Actually, it is plus P, and not minus P. 1 plus delta power P into Y naught. Now, expand this using binomial theorem. So, you will get 1 power P, that is 1. Then PC1 into delta, that is P delta. Then PC2, that is P into P minus 1 by 2 factorial delta square. Then P minus 1, P minus 2 by 3 factorial delta cube, etc. Okay. Then if I bring this y0 inside, first term you will get y0, next term you will get delta y0, and here you will get delta square y0, here you will get delta cube y0, etc. And this formula is known as Newton's forward interpolation formula, because it contains y0 and its forward differences, delta y0, delta square y0, delta cube y0, etc. Okay, therefore we call this as Newton's forward interpolation formula. Next formula is Newton backward interpolation formula, more or less the same thing, but there we will write, here we have written yp in terms of y0 and its forward differences. In backward interpolation formula, we write yp in terms of yn, that is the last value of y, and its backward differences, that is del yn, del square yn, del cube yn, etc. Okay, that is the difference. Now, Newton forward interpolation formula is used for interpolating the values of y near the beginning of a set of tabulated values and extrapolating the values of y little backward, that is to the left of y0. Okay. So we will use the Newton interpolation formula if you want to find the value of y corresponding to some x, where this x lies near the beginning of the table. Okay, for example, if it is 1, 2, 3, 4, etc., 4, 5, 6, etc. Okay, the corresponding y is given. Y value is something given here. You want to compute the value of y at 1.5. Where this 1.5 lies?
Between 1 and
it lies near, between 1 and 2. So it lies near the beginning. Therefore, we will be using Newton's forward interpolation formula. Or it may be little bit backward to the left of y0. So suppose we want to compute at 0.5. Where this 0.5 lies? That
Sir,
also near the beginning,
yes, sir.
but that is outside the interval. Here it will actually start from 1 and ends up to 6. 0.5 lies outside this one, but
Yes, sir.
slightly to the left. Okay, that's why he have mentioned here a little backward. That is to the left of this. It's not actually y0 of x0. It may be little bit left to the x0. So in these cases, we will be using the Newton's forward interpolation formula. In the same manner, we will derive the backward interpolation formula. Okay, so let's see. So what I do is I want to compute yp, but here yp I write it as in terms of xn, that is xn plus ph. For example, how will you write x0 in terms of x2?
Sir, E square x 0.
No, I want to write x0 in terms of x2. What is x2?
X
What
0
is
plus
2h,
2h. Yes, sir.
right? So what is x0? x2 minus
2h.
2h. So your
Yes,
p
sir.
is minus 2 here. So your p is minus 2.
Yes, sir.
Okay. So in the case of forward interpolation formula, we write any yp in terms of the initial value x0. But in the case of backward interpolation formula, we write yp into final value xn. So your p will be negative. Okay, if it lies this side. And xn plus ph we can write e power p of xn. E power p of xn is shifting to the p places. If p is positive,
Yes,
you
sir.
will get right side. If p is negative, you will get left side. But yesterday we have derived the relationship between E and del. We know that E inverse equal to 1 minus del,
Understand.
or E equal to 1 minus del power minus 1. Therefore, here you will get E 1 minus del power minus P into Yn. Now apply the formula 1 minus x power minus L. So 1 plus P x plus P into P plus 1 by 2 factorial delta del square, then this into del cube, this is cube, etc. of Yn. If I bring this Yn inside, you will get Yn plus P into del Yn plus P into P plus 1 by 2 factorial del square Yn, then this into del cube Yn, etc. And this is called Newton's backward interpolation formula, because it contains the final value yn and its backward differences, del yn, del square yn, del cube yn. Okay, so now compare these two formulas. In the forward we have got y0 and its forward differences. We got p into p minus 1 by 2 factorial, p into p minus 1, p minus 2 by 3 factorial, etc. What about in backward? We have got yn and its backward differences. We have got p into p plus 1 by 2 factorial. Here it is plus. Okay, there it is minus. That is the only difference.
Yes, sir.
That's and a Newton backward interpolation formula is used for interpolating the values of y near the end of the table. Okay, suppose it is 1, 2, 3, 4, and you want to compute the value of y at 3.9. 3.9 lies near the end of the table. So we will be using the Newton backward interpolation formula. Or if you want to compute the value of y at x equal to 4.1, 4.1 lies outside this. Okay, that is little ahead to the right of
It's
this
the right
xn.
by
Okay, it's right of xn actually. Okay, this is xn to the right of
yes,
this.
sir.
Then we will be using the Newton backward interpolation formula. Okay, so it's very simple. And forward y0 and its forward differences, backward yn and its backward differences. That's all. Now, for example, you take this. The given table gives the distance in nautical miles of the visible horizon for the given heights in feet above the Earth's surface. So if the height is 100 feet, the distance visible, the distance, it is 10.63 feet, etc. So at a 10, 150, 100, 150, 200, 250, etc. the values are given. So we have to find out the values of y when x is equal to 218 and when x is equal to 410, right? So where this 218 lies, it is in between
In between 200 and 250.
200 and 250. So I take this 200 as x0. It's
Okay, sir.
somehow near the beginning, so you take this as x0. Suppose if you want to compute at 151, then you take x0 as
150.
150. Suppose if you want to compute at 110, then you take
So
x0 as
100.
100. Suppose if you want to compute at 98, then also you take x0 as
100.
100. Okay, that's all. And where this 410 lies?
At the end.
At the end. So we will be using Newton's backward
Back.
integration formula, and we take this 400 as xn. That is the last value.
Yes.
Okay, that's all. So first you form the table. So this is the difference table. Write the x value, write the y value. How will you find out the first difference? 13.03 minus
10.6.
10.63. Then this minus this minus this minus this minus this minus this. Write it here. Then this value minus this value, this value minus this value, this value minus this value. Okay, subtract and write it here. Then this minus this minus this, write it here. Okay, so construct the table. Here you note that they are stopped up to del power 4. Since we are finding only the approximate answer, we can stop up to the fourth power, or if you want more closely, you can go ahead and then compute the value of fifth difference also. So here you will get two values, and then sixth difference you will get only one value.
One value.
Okay, we can go ahead and then do. But in the book, they have stopped up to fourth difference because that's itself is sufficient. But it's depends upon marks. Okay, but whatever be the problem, at least 2, 3, 4 differences you have to find. Now we will compute at x equal to 218. 218 lies somewhere in between 200 and 250. So here it lies. So I take this value as x0. X0 is 200. So what is y0? Corresponding value 15.04.
15.04.
And I told you already, when you construct the forward difference table, this diagonal will be in terms of y0 and its forward differences. Okay.
Yes, sir.
So if I take this as x0, this actually means it is x minus 1. This is actually x minus 2. Okay. Therefore, this will become y minus 2. This will become delta y minus 2, delta square y minus 2, delta cube y minus 2, delta power 4 y minus 2, etc. This is x minus 1. So this will become y minus 1, and this diagonal will become delta y minus 1, delta square y minus 1, etc. Okay. Since we have taken x0 as 200, y0 will become 15.04. What is delta y0? 1.77.
1.7.
Delta square y0 is minus
Minus
0.16. Delta cube is this, delta power 4 is this. Okay. Even when you find delta power 5, it will not be useful here. Because in delta power 5, it stop up to x minus 2. Up to here. Okay, maybe that's why they would have stopped up to this. And to compute the backward difference, what you do, you take this as xn. You want to compute at 410. 410 lies near the end. So this is yn. So what is this diagonal?
So
This diagonal will
yn
be
is
del yn, del yn, del square yn, del cube yn, del power 4,
yes, sir.
del power 5, and del power 6. Okay. Now, first write the Newton's forward interpolation formula. So this is the Newton's forward interpolation formula. We want to compute P first. Okay. So this is the formula for P. So actually we are computing at x, xp. Okay. In place of xp, I take it as x. So xp is nothing but x0 plus ph. So from this, what is P? X minus x0 by h. That is this one. X minus x0 by h. X is nothing but the point at which you want to compute the y value. So you want to compute y when x equal to 219. So x is 218. x0 is 200. Okay, nearby that we have chosen. H is nothing but the interval difference. What is the difference here? 100, 150, 200, 250. So H is 50. So I'll get the p value. Then write the Newton's forward interpolation formula. This is the formula. Y0, this one, 15.04. P is 0.36. Delta Y0 is this, 1.77. Delta square Y0, delta cube Y0, delta power 4 Y0. Substitute all this in this formula, simplify, you will get the answer. Any doubt is there? Please tell me.
No, sir.
Okay. Right? So it's clear, right? So next subdivision, we have to compute at 418. And 418 lies near the end.
And
Sorry, 410. 410 lies near the end. Therefore, we'll be using Newton's
backward interpolation.
So you take this as xn, this will become yn, del square yn, del cube yn, del power 4 yn, and write the formula for this. Xn is 400. We have chosen the point at which you want to compute, that is x, that is 410. So what is p? X minus xn by h. X is 410, xn is 400, h is the interval difference 50. So you'll get 0.2. Then write the formula, substitute all this and simplify, you will get the value of y at 410. Is it clear?
Yes.
Okay. So if it lies, first to check whether it is equally spaced. If it is equally spaced, and if you want to compute near the beginning, use Newton's forward interpolation formula. If it is equally spaced, and if you want to compute near the end of the table, use Newton's backward interpolation formula. So near the center, there are 2-3 formulas, but in your syllabus only one formula is included, called Stirling's central difference formula. Okay, that we will learn now. Next problem is this. From the following table, estimate the number of students who obtain marks between 40 and 45. So less than 30 they have not given. So we may assume that there are 0 students who has got marks between 0 to 30. So 30 to 40, 31 students are there. 40 to 50, 42 students are there. So under 51 students have scored marks between 50 to 60, etc. But how your table should look like? Your table should be in the form of
Sir, x and corresponding values of
x0, y0, x1, y1, etc.
Yes,
But here x is not in that form. It is in the interval form. 30 to 40,
Yes,
40 to 50, 50 to 60, etc. So what we can do is x I take it as marks less than particular value. Okay, so in that case, I can choose something like this. Marks less than, that I take it as x. Marks less than 40. Number of students is
31.
So less than 50 is 31 plus
42.
42. Less than 60
It's
31 plus 42 plus 51.
plus 51.
Okay, etc. So I convert the table in this one. There are 31 students whose mark is less than 40. There are 73 students whose mark is less than 50. 124 students whose mark is less than 60, etc. What we want to find? We want to find the number of students who obtain marks between 40 and 45. Marks between 40 and 45. So less than 40 already we know. Less than 40, how many are there?
31.
31. So now suppose if I compute the number of students who has got less than 45 marks, then if I subtract this number minus 31, you will get the number of students who got the marks between
40 and 45.
40 and 45. Okay. So now here our aim is to compute the value of y when x is equal to 45.
Yes, sir.
So first to construct the table. So x is 45, 45 lies near the beginning. Therefore, we use Newton forward interpolation formula. Therefore, you take x0 equal to 40. Then this will become y0 delta y0, delta square y0, delta cube y0, delta power 4 y0. Right? Then write the formula. What is the formula for P? P is x minus x0 by h.
Yes, sir.
Okay. What is x? X is 45. I want to find at 45.
45 minus 40
Minus
upon
40 divided by h is, what is the interval difference?
10.
10. So that is this. Okay. That is 1 by 2. H is 0.5. And what is delta y? What is y0? 31. Delta
Yes, sir.
y0 42. Delta square y0 9. Delta cube y0 minus 25. Delta power 4 y0 37. Substitute all this in the Newton's forward interpolation formula. This is a formula. Substitute all these values. Simplify, we get this. But we cannot say 47.87. So if we approximate, we can say there are 48 students who have secured less than 45 marks. And already from the table we know there are 31 students who have secured less than 40 marks. Therefore, the number of students who secured marks between 40 and 45 is this 48 minus 31, that is 17. So 17 students who have got the marks between
40 and
40 and
45.
45. That's it. Okay. So when the interval is not in that form, you have to convert it. Okay. Just, next problem, find the cubic polynomial which takes the following values. Hence or otherwise evaluate f of 4. Okay, so here they have not mentioned anything, but we can use either Newton forward or Newton backward. Okay, you can use anything, but here you want to compute at f of 4. 4 lies near the end. Therefore, we will be using the Newton's backward interpolation formula.
Backward difference.
Okay, but in the case of polynomial, you can use anything, and you will get both polynomials are one and the same. So either you can use Newton forward or you can use Newton backward if they mention that it is a polynomial. Okay, so how many values are given?
4 values.
So yesterday we have seen if n values are given, we can approximate by a polynomial of degree n minus 1. So here 4 values are given, so it is a polynomial of degree 3. Okay, so same thing. First construct the difference table and write the Newton forward. Just to keep this, what is P? P is x minus x0 by h. Okay, x0 is 0 here, h is 1, so P equal to x. So wherever P is there, you substitute x, substitute del y0, del square y0, etc. and simplify, you will get this polynomial. Okay, so this is a cubic polynomial that takes the values this. So in the cubic polynomial, if I substitute 0, you will get 1. If I substitute 1, you will get 2. If I substitute 2, you will get 1. If I substitute 3, you will get 10. That means that the polynomial passes through these points. Okay, maybe you can check. Okay, what is f of 0?
Sir,
all this will
1.
get cancelled. 1. F of 0 is 1. See here, 1. And put x equal to 1. X equal to 1. You will get 2 minus 7 plus 6 plus 1. 6 plus 1, 7, minus 7 cancel, so you get 2. That is here 2. Similarly, when you put 2, you will get 1. When you put 3, you will get 10. This is one way. Since you want to compute f of 4, you can use the backward interpolation formula also. Okay, I think I have not simplified, and the book they have not simplified. Just to simplify this, And you will get the same answer when you substitute x equal to 4 in the above polynomial. That is in Newton's forward. Okay. The above example shows that if a tabulated function is a polynomial, okay, so then it exactly match. Then the interpolation and extrapolation will give the same values. It means we can use anything, either Newton forward or Newton backward. If it is a polynomial, suppose it is not a polynomial, if it is some other function, then we are actually approximating that function by a polynomial. There is a difference between these two. Are you getting this?
Yes, sir.
Suppose the given values are exactly given by the polynomial, then forward and backward will give the same polynomial. Suppose the function value, whatever it is there, it is not given by a polynomial. If it is some other function, then this forward and backward, we are actually approximating that function by a polynomial. So definitely there will be a difference. There is an error. Okay. Similarly, this one in the table below, the values of y are consecutive terms of a series, of which 23.6 is sixth term. You see, sixth term is 23.6. Find the first and 10th terms of the series. So first term will be somewhere here. 10th term will be at the end. Okay, so somewhere here, 10th term. So you want to compute what will be the first and 10th term. Okay, so what will we do to find the first term? You use
Sir, Newton forward interpolation method.
interpolation formula, and for that you take x0 equal to 3.
3.
Okay, then to compute
Yes,
the 10th term, you use Newton backward interpolation
backward
formula.
interpolation.
You
And
take,
xn equal to 9.
that's all. Okay, so construct the table first. So forward, take x0 equal to this, then y0 will be this. This will become delta y0, delta square y0, delta cube y0. Delta power 4, all are 0. So all other higher powers are 0. Because it is a constant. Delta cube y is a constant. Okay, all are 0.5. So delta power 4, etc. all are 0. When you compute the 10th term, take xn equal to 9, then this is yn, del square yn, del cube yn, del power 4 yn and all 0. Okay, that's all. Then write the formula for p, substitute everything and simplify. You will get the first term and the 10th term. Okay. I have given some problems. You can try on your own. Okay. Then next comes the Stirling's formula. Okay. So the Stirling's formula is actually if you want to compute near the center. Okay. Already we have seen near the beginning, near the end. Suppose it's near the center, then we'll be using the Stirling's formula. Actually, there are a few more formulas are also there called Bessel's formula, Evert's formula and all. But in your syllabus, only this Stirling's formula is included. So I am teaching only this Stirling. Here I have given actually a rough idea of how the formula has been derived. There are two formulas called Gauss forward and Gauss backward. Earlier what we have seen is Newton's forward, Newton forward and Newton's backward. But this formula is Gauss forward and Gauss backward. Okay. So if I actually to derive this formula, what we have to do is we have to consider the Newton's formula only, but we will be rewriting the terms and then get this delta square, delta cube, etc. Okay. So that is the Gauss forward, Gauss backward. This is not in the syllabus, but the Stirling formula is nothing but the average of these two formulas. That is the mean of Gauss forward interpolation formula and Gauss backward interpolation formula. Okay, so that's why I have given the two formulas. For the proof, you may, if you actually this first this and this are not there in the syllabus. Gauss forward and Gauss backward is not there in the syllabus. Okay, so if you are Stirling is there in the syllabus. So if you are actually interested, go through the B.S. Grewal book. That is mentioned how to derive this, so you can have a idea of this one. Okay. Now, yeah, filling formula. So actually here you look at this first power, third power and all we are getting divided by 2, plus divided by 2, something like an average. Okay. And even power, it is del square y minus 1, del power 4 y minus 2. So sixth term it will become del power
6y minus 3.
3. Yeah. Okay. And first term it is del y0 plus del y minus 1 by 2. Third term it is del cube y minus 1 plus del cube y minus 2 by 2. So fifth term it will become, you see, y0 y minus 1. Then y minus 1 y minus 2. So
Then
in the
y
fifth
minus
term it will
2,
become y minus 2 and
y minus 3.
y minus 3. Okay, that is the idea. And this one actually you can write it as 1 square, 1 square. Here it is p. Third power it is p into p square minus 1 square. So fifth term will become p into p square minus 1 square into p square minus 2 square.
2 square.
Okay, so that is the general term. Here second term p square by 2 factorial. Fourth term p square into p square minus 1 square by 4 factorial. So sixth term supposed to be p square
Into p square
minus
minus
1 square into p square minus 2
2
square
square divided by
6 factorial.
6 factorial. Yes, sir.
6 factorial del power 6 y minus 3 etc. Okay, so remember
Yes.
this formula, and the same formula we can convert in terms of central difference, that is this small delta notation also. Okay, so that is the next slide. So if I convert it like this, then this is the way. So first consider this portion. Okay. That is delta y0 plus delta y minus 1 by 2. You consider this. This term, delta y0 plus delta y minus 1 by 2. So what is the actual formula of delta y0?
Sir, y1 minus y0.
Good. Y1 minus y0. The same value we can denote it by using del.
y0 minus 1.
Del, we can use the first subscript.
Yes, sir. Del 1.
Okay. The same value we can write also in terms of central differences, small delta into y. Take the
1
average
plus
of
2 by 1 plus 0 by 2.
1 by 2. So in place of this delta y0, we can write delta y1 by 2. Right?
Yes, sir.
And similarly, what is the formula for del y minus 1? What is the next value of y minus 1?
Sir, y0
Y0. Minus same value.
minus y1.
So if we want to use small delta notation, then we can denote it by small delta y
Minus 1 by 2.
minus 1 by 2. That is here. Delta y minus 1 by 2. Right? Suppose
Yes,
if
sir.
you are using the average operator symbol, what is the average operator actually?
Sir,
This
what-
plus this by 2.
Yes, sir.
So in place of this, we can write mu into delta. What is the suffix? You take the average. 1 by 2 plus minus 1 by 2 by 2. 0.
0.
So that is nothing but mu delta y0. So that is mu delta y0. Therefore, in place of this, we have got mu delta y0. Okay. In the same manner, we can prove that delta square y minus 1 is same as delta square y0. Okay. And this term, delta cube y minus 1 plus delta cube y minus 2 by 2, we can prove that is equal to mu delta cube y0. It is actually minus 1, minus 1 square. Similarly, the next term we can prove delta power 4 y0, etc. Okay. So this is the formula. This is the formula, same formula in terms of central different notation. That is in terms of delta. Okay, and it's very easy to pick from the table. You construct the central difference table exactly at the center. You will get y0, that is here. You do remember, and if I construct the central difference table in the horizontal line, only even powers you will get the value.
Yes, sir.
Okay, so that is here delta square y0, that is same as delta square y minus 1. Delta power 4 y0, that is same as delta power 4 y minus 2, etc. And whatever here mu delta y0, and what is here mu delta y0 is same as this one, that is nothing but delta y0 plus delta, this is delta y0 plus delta y minus 1 by 2. Here it is delta cube y minus 1 plus delta cube y minus 2 by 2. So what it actually is, all the odd powers in the horizontal line above and below you take the average. Horizontal line above and below you take the average. Horizontal line above and below you take the average, whatever value it is there. That is this term. That is all the odd powers. This power, this mu delta cube, delta power 5, etc. All the even powers exactly in the horizontal line you will get the value. That's it. Okay. So now let us solve some problems, then it will become clear. And this is a choice of the interpolation formula. To find the tabulated value near the beginning, use Newton forward. If it is near the end, use backward. If it is near the center, use either Stirling or Bessel's. But the Bessel is not in the syllabus. In your syllabus, you have got only Stirling. And if the interpolation is required for P, and the P lies between minus 1 by 4 to plus 1 by 4. Okay, so nearby center, this side 0.25 and this side 0.25. Then we prefer Stirling. Okay. Don't bother about the other central difference formula because it is not there in the syllabus. You have got only Stirling. There is no Bessel's, there is no Evert's formula in the syllabus. Now, listen. This is a table. We want to compute tan 16. Where the 16 lies? Near.
Sir, center.
Okay, so nearby the center. This is close to 15. Okay. And this side we
Yes,
have
sir.
got 3 value, and this side we have got 3 value. So it lies near the center. Therefore, we will be using the Stirling formula. Okay. So what you do is, you this center value you choose it as x0. Then this will become x1, x2, x3. This will become x minus 1, x minus 2, x minus 3. Then construct the table. Actually, this portion has to be little bit upwards. It should come clear. So this is 0.0015. I'm supposed to write it here. 0.0017. It has to be here. Then this
Yes,
has to
sir.
be here. Okay. So you write it in that manner, so it will become clear. So now what is P? P is x minus, here it is theta. So theta minus theta 0 by h.
By H.
Theta 0 is 15. Theta is at which I want to find, that is 16. And what is the difference? 5. So h is 5. So I'll get theta minus 15 by 5. When theta equal to 15, when theta equal to 0, you will get minus 3. So P is minus 3. When theta equal to 10, you will get minus 2. When theta equal to 5, minus 1. When theta equal to 15, 0. Then 20, 25, 30, etc. Okay. Then construct the table. This minus this, 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 write it here. Then similarly subtract this and write. So this is tan theta. Maybe you can take it as y. Then this will become delta y. This will become delta square y. This is delta cube y. This is delta power 4y. And this is delta power 5y. This I have taken as x0. So exactly at the center. What is your y0?
So
What is y0?
0.2679.
2679. Okay. So in the center line, only even values you will get. Okay. So actually this has to come above. So can you tell me odd value, odd powers above and below the horizontal line, what you will get? Even
Sir,
powers exactly on the horizontal line, what you will get?
sir,
Odd power you will get this, and
yes, sir.
even power you will get only this.
0.0045.
Okay,
Yes.
exactly at the center. And then odd power you will get this and this.
Yes, sir.
So even power you will get only this.
Yes.
Then again delta power 5 you will get this and this. Suppose you have not find they have not find delta power 6. In case if you find, you will get exactly one value that is here.
At
Okay.
center.
Therefore center. So what is the formula? Y0. What is Y0? This
Sir,
0.2679.
0.279.
That is here, 0.2679 plus P. P is this. What is this formula? You have to take the average of these two.
Average of or two.
This and this plus this by 2. That is here.
Yes, sir.
And even power, only
At the center.
this. Okay, so what is the next term? P square by 2 factorial into this. Then P into P square minus 1 square by 3 factorial into this plus this by 2. Plus P square into P square minus 1 square by 4 factorial into this. Then P into P square minus 1 square into P square minus 2 square into this plus this by 2. Then etc. this.
Yes, sir.
Okay, are you getting the idea?
Yes, sir.
Okay, that's all. So simplify, you will get the answer. The next problem, you see, at 10, 11, 12, 13, 14, it is given. We have to compute at 12.2. 12.2 lies somewhere nearby 12, so it lies in the center. So you take this as x0. We will be using the Stirling's formula. But whatever in the table, it is 10 power 5 by x. But while computing, you have to write only yx.
YX.
So what you have to do, you divide these values by 10 power 5.
Yes, sir.
Okay, so you will get this 0.22 something. So this is your x0. This is your y0. So exactly at the center, even value will coincide.
Yes, sir.
Odd value, just above and below, you will get value. Okay, so what is the formula? Y0 plus P by 1 factorial into this value plus this value by 2 plus P square by 2 factorial into this value.
Yes, sir.
Plus P into P square minus 1 square by 3 factorial into this value plus this value by 2 plus P square into P square minus 1 square by 4 factorial into this value.
Yes, sir.
That is here. Okay. So all the odd powers, you will get the average. It is okay. And all the even power, it will exactly coincide with the center line, horizontal line. Okay, that's all. So I'll stop up to this. So in the next class, we will continue with the interpolation with the unequal intervals. Okay. So today we have seen interpolation with the equal intervals. There are three formulas: Newton forward, Newton backward, Stirling's central difference. If you want to compute near the beginning, Newton forward interpolation. If you want to the end, Newton backward interpolation. If you want to compute near the center, Stirling's formula. Okay, that's all. I'll stop up to this. I think possibly tomorrow it will be holiday. Okay. They are selling that some puja, chat puja, something is there. But till now, I have not received any notification. So tomorrow, if it is holiday, we will meet on Monday. That is
Yes, sir.
next class. Okay. Otherwise, we will continue on tomorrow. Okay. Just fill the attendance and leave.
Thank you, sir.
Thank you. Bye.